You know, when you think about the most powerful technology in the world, it's often not the flashy app on your phone. It's the invisible infrastructure running everything in the background. Well, today, we're going to pull back the curtain on one of those secret engines, a project that's been decades in the making and is now the quiet force powering the future of Korean AI.
Okay, so let's just start with the big question that gets to the heart of all this. How do we get computers to go beyond just crunching numbers and actually truly understand the world? To understand the meaning and the relationships behind all the data we feed them. It's really the difference between a computer just knowing a word and actually understanding a whole sentence.
And the answer lies in this really cool concept called ontology. Now, I know the name sounds super academic, but don't let that fool you. The idea is, honestly, brilliant in its simplicity. See, if a regular database is like a dictionary, just a big flat list of words, an ontology is more like a thesaurus. It doesn't just list things, it shows you how they're all connected. It understands the relationships, and that provides context and meaning.
To really get why this matters so much, we've got to rewind the clock a bit. Because this whole project wasn't born out of the AI hype we're seeing today. No, this was a calculated, long-term bet on the future of the internet itself, a dream that started way back in the 90s.
Right. So back in the late 90s, the big thinkers behind the internet had this huge dream of what they called the semantic web. The whole idea was to build a version of the web where information wasn't just for humans to read, but was structured so that machines could understand what it all meant. That would allow them to search and reason about things in a way that was just way more intelligent.
Now, while a lot of the global hype around the semantic web kind of faded for a while, South Korea made a really strategic choice. They doubled down. Instead of just hoping the market would figure it out, the government, through its top research institutes like ETRI and KISTI, decided to invest heavily. They treated this not as some product for a quick profit, but as fundamental national infrastructure, like building highways or a power grid for knowledge.
So, you're probably wondering, how do you actually build a thesaurus for computers? Well, it turns out the key is to break down knowledge into its simplest possible form.
And that simplest form is this really elegant little structure called a triplet. Think of it like a single Lego brick of knowledge. It's designed to state one single, totally unambiguous fact about the world.
And the anatomy of a triple is beautifully simple. It just has three parts. First, you have a subject. That's the thing you're talking about. Then a predicate, which is just the relationship. And finally, an object, the other thing it's related to. So, for example, Seoul is the subject, is the capital of is the predicate, and South Korea is the object. That's it. One fact, one triple.
Now, one triple on its own is just one tiny fact, but this is where the magic really happens. You create millions, even billions of these triples. And because the same thing, like South Korea, can be an object in one triple and a subject in another, they all start to link together. What you end up with is this massive, interconnected web of facts, a knowledge graph.
Of course, Korea didn't do all of this in a bubble. The researchers were really smart about it. They built on top of international standards as they evolved. They started in the early 2000s with languages like DML plus OIL for some early projects, like cataloging cultural content. Then they adopted the core standards, RDF for creating all those basic triples, and then OWL, which is a richer language that lets you define more complex rules and relationships. And finally, to actually ask questions of this giant brain, they adopted SPARQL, which is basically the search language for this new world of connected data.
And let's be clear, this wasn't some little lab experiment. They built the heavy machinery to make this work at an industrial scale. We're talking distributed servers and high-performance engines that can store and search through billions of these facts almost instantly. This was some serious, heavy-duty infrastructure development.
So for years, this was largely a public sector project, right? Building the foundation. But then, starting in the 2020s, bam, everything changed. The AI revolution we're living through right now created the perfect moment for a whole new generation to step up and take the lead.
You can really think about this story in two parts. The first generation, led by public institutes like KISTI and ETRI, was all about building that foundation. Their goal was to create core tech and a public good. But the second generation, led by private companies like Sky Worldwide and 88, has a different goal. Take that foundation and build commercial AI infrastructure on top of it.
So this pivot is absolutely crucial to the story.
The mission was no longer just about organizing knowledge for academics and researchers. It became about using this incredibly powerful knowledge graph as the bedrock to build smarter, more capable AI systems for actual businesses and industries.
Okay, so that's the history, that's the tech. But what does this actually look like in practice? How does this decades-old dream of a semantic web really help a modern AI make smart decisions today?
Well, this is where solutions like Ontobia come into the picture. It's developed by the private company Sky Worldwide, and it's the first homegrown commercial AI ontology solution of its kind in Korea. Basically, its job is to take all of a company's messy, raw data and transform it into one of these structured, AI-ready knowledge graphs. And it's now being rolled out for really complex industries like finance and manufacturing.
So when you zoom out, you can really see this whole amazing ecosystem that's been built over the years. It started with the founders, the public research groups like KISTI and ETRI that built the core tech. Then you had the enablers, who built the industrial-scale servers and search engines, and now you have the commercializers who are creating real-world solutions like AI platforms and digital twins for smart factories.
But here's the thing, and this is probably the most exciting part of this whole story. The ultimate goal of all this work has evolved. It's no longer just about making an AI that can give you a slightly smarter answer.
The real prize now, the holy grail, is explainable AI or XAI. You know how we're all a bit worried about AI models being these black boxes that just spit out answers with no reasoning? Well, XAI is the mission to build systems that can actually show their work.
And that, right there, brings us completely full circle. Because when an AI is working with a knowledge graph that's built from millions of these clear, simple facts, those triples we talked about, it can literally trace its steps. It can tell you, I made this recommendation because of this fact, which is connected to that rule, which is related to this other piece of data. The ontology provides the map that allows the AI to explain its journey.
So, I'll leave you with this question to chew on. What happens when the AI systems we rely on every day, in finance, in medicine, in our daily lives, can finally truly explain the why behind their decisions? What changes? That is the future that this quiet, decades-long investment is finally starting to unlock.